PSMBE 102 Construction Economics. An introduction to the basic concepts. In this first chapter, we outline the main characteristics of firms involved in construction markets, introducing the complexity of the construction process and the diversity of activities. It aims to sense that there are several possible ways to describe the construction industry and identifies a range of activities that includes a broad definition of the industry. An introduction to the basic concepts similarly divides the construction process into several professional stages. It outlines a simple classification system that defines the industry as firms constructing and maintaining various buildings and infrastructure. Who are the construction industry? Broadly defined, the key actors include suppliers of primary materials, e.g., sand, cement, aggregate, and bricks, manufacturers of site equipment, such as cranes and bulldozers, manufacturers of building components, e.g., windows, doors, pipes, and radiators, site operatives who bring together members and materials, project managers and surveyors who coordinate the overall assembly, architects and engineers who design new buildings and infrastructure, facility managers who manage and maintain the property, property developers who initiate new projects, providers of complementary services, such as demolition, disposal, and cleanup. Introducing construction economics. Construction economics, like pure economics, is concerned with allocating scarce resources. But unfortunately, many of the world's resources, factors of production such as land, labor, capital, and enterprise, are finite, yet people have infinite wants. To reconcile this problem, economists argue that people must make careful choices about what is made and how it is made. In a world of scarcity, for every want that is satisfied, some other want, or wants, remain unsatisfied. Choosing one thing requires giving up something else. An opportunity has been missed or foregone. This is the concept of opportunity cost. Opportunity cost is the value of the alternative foregone by choosing a particular activity. This way of thinking emphasizes that whenever an economic decision is made, there is a trade-off between using one resource for one or more alternative services. From an economic viewpoint, the value of a trade-off is the real cost, or opportunity cost, of the decision. As a general rule, resources are rarely equally adaptable to alternative projects. In construction or any other economic sector, it is rare to experience a constant opportunity cost ratio, in which each production unit can be directly adapted to an alternative use. Instead, it is far more common in business trade-off decisions to see each additional production unit cost more in foregone alternatives than the previously produced unit. This rule is formally referred to as the law of increasing opportunity costs. A nation can have more military goods, guns, or civilian goods, butter, but not equal proportions. The opportunity cost of an additional unit of military goods will be higher when we use inappropriate resources for the task. This can be illustrated with the guns or butter argument. Units of military goods per year, units of civilian goods per year. Using these curves, it is possible to show the maximum amount of output that can be produced from a fixed amount of resources. We show a hypothetical trade-off between units of military goods and civilian goods produced yearly. All resources would be used to build military goods if no civilian goods were delivered. At the other extreme, if no military goods were produced, all help would be used to produce civilian goods. Points A and F represent these two extreme positions. Points B, C, D, and E represent various other combinations that are possible. If these points are connected with a smooth curve, society's production possibilities curve is obtained, demonstrating the trade-off between the production of military and civilian goods. These trade-offs occur on the production possibility curve. The curve is bowed outwards to reflect the law of increasing opportunity cost. If the trade-off is equal, The curve will not bow out. It will simply be a straight line. Points show other interesting observations arising from the production possibility curve G and H. Point G lies outside the production possibility curve and is currently unattainable. Still, it does represent a target for the future. Point H, on the other hand, lies inside the production possibility curve and is achievable, but it represents an inefficient use of available resources. The production possibility curve is based on the following assumptions. First refers to the possible output yearly. In other words, we have specified a period during which production takes place. Second, we are assuming that resources are fixed throughout this period. To understand what is meant by a fixed amount of resources, consider the two lists that follow. A. Factors that influence labor hours available for work. B. Factors that influence productivity, or the output per unit of input. Factors influencing labor hours available for work. The number of labor hours available for work depends on the nature of human resources in society. The number of economically active people that make up the labor force depends on the size of the population and its age structure, as children and retired persons will be economically inactive. The percentage of the labor force who then choose to work. Prevailing customs and traditions, such as typical length of the working week, number of bank holidays, etc. Factors influencing productivity. There are several factors influencing the productivity of an economy or sector of the economy. The quantity and quality of natural and manufactured resources. The rate and extent of the education and training of the labor force. The levels of expectation, motivation, and well-being. The commitment to research and development. Third is that efficient use is being made of all available resources. In other words, society cannot, for the moment, be more productive with the present quantity and quality of its resources. Given the current level of resources in construction, it should be possible to increase productivity by at least 10%. In other words, a production possibility curve representing all construction activities could be pushed out to the right. Several standard sets of problems are identified as the root cause of this inefficiency. First, the industry demonstrates a poor safety record and an inability to recruit qualified staff. Second, there appears to be no authentic culture of learning from previous projects and no organized career structure to develop supervisory and management grades. Third, great concern is expressed about the poor level of investment into research and development that restricts the industry's ability to innovate and learn from best practices. The fourth, possibly most worrying, the problem is that technology, in the sense of innovation, information modeling, and off-site assembly, is not used widely enough across the construction sector. Another possible scenario suggested by the production possibility curve approach is that the construction industry may currently work within the boundary of its production curve. Say, point A in Figure 1.2. In this case, an increase in output could be achieved by greater efficiency. Supply constraints need to be reduced. The problems identified by the government reports resolved, and the factors generally acknowledged to increase productivity, listed above, must be addressed to achieve the industry's full potential. These scenarios are shown in Figure 1.2 and support the idea that the construction industry's productivity level needs to improve. In very general terms, therefore, the study of economics is concerned with efficiently using limited resources to maximize output and satisfy the most significant possible number of wants. In short, the basis of the subject rotates around the concepts of choice, scarcity, and opportunity cost. Infrastructure, buildings. In this diagram, we show two scenarios. A. Improved productivity shifts the entire production possibility curve outwards over time. B. Output can be achieved more efficiently by moving to a position of full potential on the actual production possibility curve. In modern society, economics is involved in all activities producing goods and services. As a result, a range of specialisms has evolved out of mainstream economics. For example, students reading for degrees in catering, sports, leisure, publishing, retailing, or computing do not benefit from specialized literature in economics. The construction industry has 5 distinct qualities. These include the industry's size, its profound contribution to a nation's standard of living, and its product's unique characteristics. The physical nature of the product is large, heavy, and expensive. The construction industry is dominated by many relatively small firms spread over a vast geographical area. Demand for activity within the sector is directly determined by the general state of the economy as a whole. The method of price determination is unusually complex due to the tendering process used at various stages. Most projects can be considered as a one-off, as there is usually some defining quality that makes them, in some ways, unique. These qualities alone have justified several dedicated academic publications. The first edition of these was Patricia Hillebrandt's Economic Theory and the Construction Industry, published in 1974, with new editions in 1985 and 2000. Subsequently, several other titles followed, notably the 2-part text co-authored by Ive and Grunberg, 2000, and the edited volume by Gerard de Valence, 2011. In 1982, Construction Management and Economics, a specialist refereed journal, began to report on research contributing to the new subject specialism. The journal continues to be published monthly, and several papers have been selected as good readings to consolidate the 3 sections of this textbook. Another relevant academic journal is Building Research and Information. This interdisciplinary focus links the built, natural, social, and economic environments. Consequently, many of the papers in this journal contribute to our understanding of how buildings and infrastructure impact ecology, resources, climate change, and sustainable development. Appropriately, several examples are cited as references. In recent years, several academic studies have highlighted the inefficiency caused by the construction industry. It is commonly observed that many projects run over budget and are delivered late. It should not be acceptable for construction projects to fail cost-wise, time-wise, or client-wise. There is no coherent conceptual consensus about what constitutes construction economics. George Afori. Construction economics cannot be regarded as a bona fide academic discipline. Hillebrandt defines construction economics as studying the construction firm, the construction process, and the construction industry. There is a lack of consensus on how to engage constructively and sustainably using the enormous contribution the construction industry makes to a country's economy and social and environmental well-being. This text argues for a new approach that considers the increasing importance of strategies aimed at achieving sustainable construction. Introducing sustainable construction. The UK government's strategy for sustainable construction was published in June 2008. Similar agendas have emerged in Europe, North America, and some developing countries. The strategy aims to provide a catalyst for change in the way we construct buildings and other structures. Efficient use of resources. Adequate protection of the environment. Economic growth. Social progress that meets the needs of everyone. Each of these strands is underpinned by financial concepts. Part A: effective use of resources. This deals with microeconomics and outlines the various ways of efficiently allocating resources between competing ends. This section focuses on the determinants of demand and supply for infrastructure, housing, industrial buildings, commercial property, and repair and maintenance. Part B: protection and enhancement of the environment. This section considers failures of the market system, drawing upon various environmental and economic concepts and tools to encourage future construction industry members to evaluate projects by more than just financial criteria. Part C: economic growth that meets the needs of everyone. This section incorporates coverage of the broader macroeconomic scene. It outlines the various government objectives that must be achieved alongside sustainable construction. It highlights the difficulty of managing an economy and the need for professionals working in the construction industry to acquire an economic vocabulary. To summarize, the construction industry can be described in several ways. Construction has 5 distinguishing characteristics. Each project is regarded as a unique one-off product. The industry is dominated by a large number of relatively small firms. The general state of the economy influences demand. D. Prices are determined by tendering. Projects are characterized by their lumpiness in scale and expense. The basis of economics rotates around the concepts of choice, scarcity, and opportunity cost. Hence, economics is the study of how we make choices. Any resource use involves an opportunity cost because an alternative service is sacrificed. The graphic representation of the trade-offs that must be made can be displayed in a production possibility curve. Sustainable construction is a strategy aimed at encouraging the industry to use resources more efficiently, limit the environmental impact of its activities, produce buildings and infrastructure that benefit everyone. Introducing economic vocabulary. Economics employs its methodology and language. Resources. Economists use the term resources to highlight that only by combining various factors can produce goods and services. These factors of production are usually categorized into 3 general groups: land, capital, and labor, and sometimes, the entrepreneur is specifically identified as a 4th entity. The contribution of labor to the production process can be increased. When there is an improvement in human resources, we say that human capital has been improved. A relevant example is the effect well-trained management can have on the efficiency of a whole project. Management expertise is one of the world's scarcest resources of the construction industry. Each new construction project has a choice about the materials used and the proportion of labor, plant, and equipment required. Construction tends to be dominated by input costs relating to materials, components, and work. The importance of the entrepreneur should not be overlooked, as without a dedicated resource managing and coordinating the other factors of production, virtually no business organization could operate. Market systems. The market concept is somewhat abstract in that it encompasses the exchange arrangements of buyers and sellers for a particular good or service. The difference, however, between one market and the next is the degree of formality in which it functions. By contrast, construction markets are less structured and informal and are usually determined by geographical location. The construction industry is concerned with producing and maintaining a wide variety of durable buildings and structures, and as a consequence, there are many construction markets. The construction industry is concerned with creating and maintaining various durable buildings and structures. Drew and Skidmore, 1997-470, concluded in their analysis of the competitive construction markets that the construction industry is highly fragmented, with the dominant firm being the small contractor. The type of construction, particularly in terms of size and complexity, will define the market in each case. Parties traditionally supplying a construction project, architects and designers, provide specialist advice concerning structural, electrical, mechanical, and landscape details. Identify key specifications. Project manager manages projects in detail. Liaises between the client and the construction team. Cost consultant prepares bills of quantities, cost plans, etc. Main contractor manages work on site. Subcontractors supply specialist skills. Suppliers provide building materials and components. The costs per square meter are likely to increase if a construction project is very complex and massive. The idea of complexity is fundamental in construction markets as it determines the number of businesses interested in competing for the work. In most cases, firms will not bid for work beyond their local district as the costs of transporting materials, plants, and labor are relatively expensive. Complexity plus large size equals competing firms from a wider geographical area. The rule of thumb states that the total number of firms interested in work of a particular type can be referred to as comprising the local market. The construction industry should, therefore, be defined as those firms willing and able to compete for a contract in a specific geographical area. In construction, the services of one firm are often easy to substitute by contracting another firm with the same type of expertise. In addition, the construction market refers to a diverse and broad range of activities in many markets. As a result, prices in construction markets often find their level. A complex set of markets for one building project. Building inception, construction markets, building completion, key resources of construction firm, stage or operation. The example of one building project, the construction process from inception to completion comprises several different markets. Figure 3 highlights the number of fragmented activities in completing just one small building. The next project in a firm's market sector may compete for its attention while finishing the current project. Methodology. This introductory chapter aims to explain what construction economics is all about. In general terms, economics is a social science that attempts to use the same methods as other sciences, such as biology, physics, and chemistry. Apart from identifying the central concepts, we need to consider the practices employed by economists, as the approach taken to a discipline helps specify the subject's nature. Economic models are simplified representations of the natural world that we use to understand, explain and predict economic phenomena. Most of the models presented in this text consist of verbal statements, graphs, and mathematical equations at the more advanced level. Many of the processes in the industry do not lend themselves easily to generalizations and models. These models may take various forms, such as verbal statements or numerical tables and graphs. As the text progresses, you will notice striking parallels between then and now. The critical point we are attempting to make is that an economic model cannot be deemed unrealistic simply because it does not represent every last detail of the natural world it is trying to analyze. On the contrary, it is worthwhile if the model clarifies the central issues under consideration. The circular flow model represents a simplified, scaled-down economy in which relationships only exist between households and businesses. It analyzes income flows around an economy by ignoring the government, financial, and overseas sectors. The bottom loop is shown in Figure 4. It assumes that households sell factors of production to businesses and, in return, receive income in the form of wages, interest, rents, and profits. The companies sell finished goods and services to households for household expenditure. Production will necessitate buying land, labor, capital, and enterprise. Businesses will only make what they can sell. These assumptions are reasonably realistic. The circular flow model. A two-sector economy. Businesses, households, household expenditures, goods plus services, factor services, labor, land, capital and entrepreneurial activity, wages plus rents plus interests plus profits. This simplified model only includes households and businesses. The flow of goods and services in return for money is one way. The circular flow is the best way to describe this exchange. The role of governments and financial institutions. Because of the importance of the construction industry to the overall health of the economy, most governments are concerned that it becomes a highly efficient sector. The government's role as a client, regulator, policymaker, and change sponsor is mentioned several times throughout the text. At the start of 2016, the construction sector had yet to return to pre-recession output levels. As stated in the preface, any self-respecting economics text must reference the financial crisis precipitated by the 2007 credit crunch, especially since it continues to trouble economies worldwide. The financial sector is vital in economic management and construction project financing. Environmental economics. Adequate protection of the environment forms a vital part of any text concerning sustainability. Environmental economics is essential for several reasons. The environment has an intrinsic value that must not be overlooked. The sustainability plan extends the time horizon of any analysis to assure equity between generations. The demands must be viewed on a whole-life basis. Any model of analysis that seeks to identify general principles of sustainable development must include microeconomics and macroeconomics. Economics is typically divided into two types of analysis: microeconomics and macroeconomics. Microeconomics is the study of individual decision-making by both individuals and firms. Macroeconomics studies economy-wide phenomena resulting from group decision-making and entire markets. As such, it deals with the economy as a whole. Microeconomics is concerned with determining how prices emerge and change and how firms respond. In contrast, questions relating to the rate of inflation and the growth rate of the whole economy fall in macroeconomic analysis. In other words, macroeconomics deals with aggregates or totals. Modern economists are increasingly using microeconomic analysis as the basis for macroeconomic analysis. You should be aware of the blending together of microeconomics and macroeconomics. Studying any specific industry involves microeconomic and macroeconomic approaches, mainly when the sector is multi-product and has national and international significance. In some texts, a sectoral approach is referred to as mesoeconomics, derived from the Greek word mesos, meaning intermediate. Throughout this text, the interaction between the construction sector and the other sectors of the economy is a constant reference point. This is done to clarify that the study of any specific sector or industry inevitably falls between the conventional microeconomic and macroeconomic categories. To gain a comprehensive understanding of construction activity, it is necessary to embrace three perspectives. These include a macro overview of the economy, a sectoral study of the industry, and a detailed microanalysis of the individual markets in which construction firms operate. Studying the complete text, therefore, should provide a greater understanding of winning and completing projects efficiently and sustainably. A model for construction economics, a new approach: projects, firm, industry, economy, sustainable construction issues. Critical summary and points 2. We need to use scarce resources, such as land, labor, capital, and entrepreneurship, to produce any economic good or service. The exchange of information between buyers and sellers about factors such as price, quality, and quantity happens in a market. Construction comprises a diverse range of needs, as the industry consists of many relatively small firms. Every economic model, or theory, is based on a set of assumptions. How realistic these assumptions are is not as important as how effective they make the model or theory. Microeconomics involves the study of individual decision-making. It consists of analyzing aggregates. Mesoeconomics combines the territory shared by microeconomics and macroeconomics. Its goal is to study a specific sector, such as construction. Introducing construction industry activity. Industrial classification favors a narrow definition of the construction industry that includes only firms involved with building and civil engineering. This categorization is derived from the United Nations International Standard of Industrial Classification, ISIC. There are also American and European equivalents: the North American Industry Classification System, NAICS, and the General Industrial Classification of Economic Activities, otherwise known as NACE. The construction industry is defined by sector, areas of construction, examples of the type of work, infrastructure, water and sewerage, energy, gas and electricity, roads, airports, harbors, railways, housing, public sector, e.g. housing associations, private sector, e.g. new estates, public non-residential, schools, colleges, universities, health facilities, sports and leisure facilities, police and fire stations. Public industrial, factories, warehouses, oil refineries. Private commercial, PFI, and similar public partnerships, schools, hospitals, where privately funded, restaurants, hotels, bars, retail, outlets and shops, offices. Repair and maintenance, extensions and conversions, renovations and refurbishment, planned maintenance. Key points. The construction industry may be defined in many ways, but its impacts always cut right across the economy. A narrow definition of the construction industry includes the erection of buildings, infrastructure work, repair, maintenance and demolition. A broad definition of the construction industry adds to the narrow definition by including the mining and quarrying of raw materials, manufacturing and selling construction products, and related professional services.